Here is our final installment of Lesson 5.7, Double Angle and Half Angle Identities. We already verified the different identities, and we used identities to find exact values of some new or different rating values. And now we're going to verify some identities. So it says these last two examples are prove, or we can use the word verify. Prove cosine of 2x equals cosine to the fourth x minus sine to the fourth x. Remember, we first determine which one is more complicated. There might be an argument for both since we have this 2x here, but I'm going to say the right side is more complicated. Now, what I would do is realize that this is cosine of 2x, which this lesson is about double angle identity. So realize we're going to try to get probably one of these boxes. So either the green one, the blue one, or the black one. We're going to try to get something like that on the right side, and then we know it's equal to the left side. Well, cosine to the fourth x minus sine to the fourth x. We know cosine of 2x from I just mentioned is actually a cosine squared x minus sine squared x, which looks kind of like this. And this is actually, we can do a difference of squares. So if we remember a squared minus b squared, we know factors into a plus b times a minus b. And this kind of fits that form. So we can factor this into cosine squared x plus sine squared x times cosine squared x minus sine squared x. And so what we did there is we factored. I've been writing the reason why we do things. So this is, we factored. Well, what do you notice here? Hopefully these things are starting to jump out at you. We have a sine squared x plus cosine squared x. That equals 1. So it's just equal to 1. Cosine squared x minus sine squared x. So right there, we just used the Pythagorean identity. And now, as mentioned before, we just learned in this lesson that this right here, that's one of our identities for cosine of 2 theta. So that equals cosine, well, we're using x, so cosine of 2x. And that is equal to what we are trying to get. So we verified that trig identity. All right, the last one. Once again, we have cosine of 2x, so we might want to get it in one of those forms that we've talked about before. So let's see what we can do here. Looks kind of, the right side definitely looks more complicated. So as mentioned before, if you see ones with squareds, you can look to the Pythagorean identities. And there is a Pythagorean identity that says 1 plus tangent squared theta is equal to secant squared theta. So this denominator, we can just change to secant squared theta. X, sorry, we're using an x here, secant squared x. The numerator, don't know what to do with that yet, so let's leave it as is. So we used a Pythagorean identity. Well, here's where my mind is going. I know that cosine of 2x, in all three identities that we talked about above here, it always has two terms. Kind of making a mess of what I have written here, but it always is in two terms. And the reason I mention that is down here, on the right side, we kind of have two terms. We have two terms in the numerator. And so my thought would be, well, let's use this common denominator of secant squared and split that into two separate fractions. So we can say this is 1 over secant squared minus tangent squared over secant squared. So we're using the idea that that's a common denominator. Normally we combine two fractions into one, but now we're going to separate it. We can only do that when the addition or subtraction's in the numerator. We can't split up a denominator. So what do we do here? We just used a common denominator. All right, looks like we're getting somewhere here. 1 over secant squared, we know that's cosine squared x by reciprocal. So that gets it somewhere, so we have reciprocal. Now over here on the next part, we have tangent squared and secant squared. Probably just going to change both of these to sine and cosine for right now. Or we could just think of tangent squared actually is secant squared. Now let's go to sine and cosine. So tangent, using the quotient identity, we know that's sine squared over cosine squared. That's the numerator. So we use the quotient identity for the numerator. And then secant squared is 1 over cosine squared. So we used reciprocal again. So we used several identities just in that one step. Well, we have cosine squared. Well, what happens here, we can multiply top and bottom by cosine squared to simplify this compound fraction. And the reason we do that is because if you multiply by the reciprocal of 1 over cosine squared, they'll cancel, and we no longer have a denominator in the compound fraction. Well, in this one, the cosine squared also cancels here, so we're just left with sine squared. I would say we did some simplifying there. So we simplified the compound fraction. Well, now that you see what we have, you might recognize this as the identity for the cosine double angle identity. So this is equal to cosine of 2x, which is what we wanted. It's equal to cosine of 2x. And there is the completion of lesson 5.7.